So, hello everyone. Sorry for the change of venue, remote venue issues with Zoom. But welcome to our September 2022 meetup. So, the Open Source Satellite Programme holds regular meetings, meetups on a wide range of topics across the space industry, from applications through modelling, some technical topics, science topics, hardware related, and anything basically in the wider space ecosystem. So we've established the Open Source Satellite Programme with the vision of making space more accessible and also to promote the responsible and sustainable utilisation of space. Through the team's own personal experiences within the industry of designing, building, operating spacecraft, we've seen firsthand the utility that small satellites, the ideas and markets they have stimulated, and the value that they've brought to many sectors and industries. And we see this trend continuing into the future, where the potential for small satellites to influence and make a positive impact to everyone's lives. The Open Source Satellite Programme is developed for the open source community by the open source community, and you could get involved, and I'll talk about that at the end of the presentation. So we've had a short break since our last presentation from Dawn Aerospace. Thank you ever so much to those guys. That was fantastic. And it's a pleasure to restart today after the summer break. So this afternoon, I have the great pleasure of welcoming Sufi to talk about satellite constellations, what they are and some examples of them. And we would also like to close that talk by an open discussion on the growth of constellations and what that means for the wider space industry. Anyway, so I shall hand over to Sufi to begin. Okay, thank you.
Hi everyone, thanks for the introduction, Catherine. So I'm Sufyaan Akram. I'm an engineer at KISPE. So I joined KISPE about 3 years ago, straight out of university, working on space situation awareness and helping out with systems engineering and more recently more mechanical engineering side of space engineering. So generally working on some exciting stuff at KISPE. So today I'm hoping to talk about constellations, why we use them, how we've got to where we are now, and hopefully open up the floor to a discussion on what we think about constellations and what the future looks like for them and the space environment in general. So what are constellations? At the basic level, they're the use of multiple satellites to work together to make a system that provides a better solution than a satellite individually could provide. So a typical example would be where a single satellite can only monitor a certain percentage of Earth at a certain time. By using multiple satellites in similar orbits, you can get a greater coverage of Earth and provide a better solution over the same amount of time. So typical area and use of constellations is in the low Earth orbit region. So low Earth orbit constellations make use of the low Earth orbit environment, typically with comms and Internet of Things, making use of the low latency that low Earth orbit provides to get higher amounts of data quicker back down to the ground. It's also useful for Earth observation, as the low Earth orbit allows us to get high resolution data when we're doing remote sensing. To get that global coverage, it requires a large number of satellites, as the footprint seen by a single satellite is smaller than at higher altitudes. And typically in these low Earth orbit constellations, you would mostly use small satellites compared to satellites in higher orbits. So another region of another type of constellation is the medium Earth orbit type of constellation. So that's looking at satellites in the medium Earth orbit altitude range, and typically we use that for GPS and use that for navigation constellations, so, such as GPS and Galileo. But they can also be used for comms, such as O3b. So you'd use this altitude typically as it gives a good mid ground between the coverage that is seen by a satellite as well as midground between the latency. So it's a higher latency than seen at low Earth orbit, but still lower than geostationary satellites. And this altitude allows you to use less satellites to still get that overall global coverage. There's an example there to show how many satellites are visible on the ground from that GPS constellation at a single point. So then you also have the geo type of constellation. So an example of that is the Inmarsat constellation, which is used for comms. And you also have satellites that are used for Earth observation in the GOES constellation. So that provides a much greater coverage of Earth. As you can see, you only need 3 satellites to get a global coverage, but it does introduce higher latency. A big benefit of using a geo constellation is that you get permanent ground coverage, as you are basically staying stationary above a point on Earth. A drawback of this type of constellation, though, is that you typically do not get polar coverage unless you are in a more unconventional orbit. So the way to describe a typical way to describe constellations is by using the Walker Delta pattern notation. So you can see that in the bottom right corner, and that allows you to describe the number of satellites that you have, the inclination that you'd put them in, put their orbit in, and how these satellites are distributed between the number of orbit planes and how those planes are also distributed relative to each other, and typically using the phasing of the right ascension. A constellation that we probably all have heard of is the mega constellation, which uses typically hundreds to thousands of small satellites. And this is typically useful for high bandwidth comms and comms constellations such as Starlink, which uses thousands of satellites in low Earth orbit, able to communicate at pretty much almost global coverage. So I'm just going into a quick stop timeline of how constellations have got to where they are now. So the earliest example of constellations can be shown with the Molniya 1 satellites, which were fairly sizable and were started to be launched in 1968. And these were providing military and civilian communications to the Russian territories. So this type of orbit is a atypical orbit with the Molniya orbit, as it's now typically known as, with a high apoapsis that allows it to have that long dwell time of the regions of interest, which in this case is the Russian territories. And for this constellation to work to have a consistent coverage, you would need 3 in that orbit. So these satellites, because of that very low periapsis, as you can see in that 0.0 on that graph, they typically did not have a long lifetime. So these satellites were routinely replaced. And we've had 94 of those launches up until as recent as 2004. So moving further on into the 90s, we have the Iridium constellation. And so that was a L-band voice and data service that allowed the use of satellite phones. That had 66 satellites in low Earth orbit with 6 polar orbits phased at 30 degrees apart with 11 satellites per orbit. And as you can see from that graph, that gave a pretty consistent global coverage. That the satellite mass now is reduced to 150 kilograms, so a much smaller satellite. So the Iridium constellations that should be added to, and I think maybe replaced by the Iridium Next constellation, which I don't have too much more information about that, but I'm sure people have heard it mentioned before. And most recently, as a lot of people will probably have heard of, is the Starlink low Earth orbit constellation, which is an internet provider service, and there's currently 3,000 satellites in orbit, with plans for many more coming soon. So this provides internet coverage globally, and the satellite mass is around 260 to 295 kgs. So it's still within the small satellite range that started in 2019. As you can see from this graph, the number of constellations has grown pretty much almost exponentially, starting from with a peak, starting to peak from around 2017 to 2018, and with a slight dip accommodating for COVID and how that affected certain launches. It came back quite strongly with 76 launches just this year, or at least, and planned launches for the following few years. So you can see that constellations have become much more popular in recent years. And with this, the number of objects that are now orbiting in space has grown exponentially to with 1,807 known objects. So what does the future look like? So the future is pretty much dominated by these mega constellations, with Starlink Phase 2 and beyond having 7,500 planned satellites, with approval awaiting for at least 12,000 more. Another constellation that's being planned is eSpace, with very small satellites being proposed in the 10 kilogram size, hoping to provide secure comms, and they have planned 100,000 to 327,000 satellites. So in some literature from eSpace, they have said that these satellites will be designed to clean space by helping to deorbit some of the very small space debris, and have been designed to not cause more debris once these satellites have been used up. So how accurate that statement is dependent on what data they've actually provided on how they plan to do this. But this is currently what they have planned and mentioned. The Astra mega constellation is also planned in 3 separate phases, with a total of 13,000 plus satellites that have been planned. And this is to provide comms and broadband from the China SatNet network. And you also have the Amazon Kuiper Systems mega constellation, which is also hoping to provide satellite internet service, with 3,000 satellites currently planned. So now I'm hoping to bring it to more of an open discussion, and to hear what the rest of you think of mega constellations and what the future looks like for specifically low Earth orbit. As you can see from that very cluttered picture, there's currently 36,000 space debris objects greater than 10 centimeter that we are currently tracking. And from an article on space.com, a researcher has found that they believe that the Starlink satellites I previously mentioned, is now responsible for half of all close encounters between 2 satellites. So they are predicting that these mega constellations are going to be causing a greater risk for in-orbit collisions and contributing to more space debris, which could render low Earth orbit almost unusable. Because of these impacts, there's an increasing pressure now to deorbit in a shorter time frame, as was announced recently that there's now pressure to deorbit within 5 years once your mission is complete. Please correct me if I'm wrong on that number. And there's now a greater requirement for satellites in lower orbit to have collision avoidance capabilities, and there's an increased drive to be able to track satellites accurately, so that they are now able to move out the way to avoid these collisions. Mega constellations have been affecting astronomy, as you may have seen in recent news articles, that the Starlink satellites have again been causing issues by leaving streaks in astronomy astronomical photographs. So this photograph from the Zwicky transient facility at Mount Palomar highlights this effect quite obviously with that streak down the middle right there. And they predict that they found that 20% of the images that they took from 2021 had these streaks in them. So that's a fifth of the images that were basically affected. So Starlink has tried to mitigate these issues by installing visors to reduce the apparent brightness of the Starlink satellites to reduce that streaking effect, and they've managed to reduce that by a factor of 5. So whether that is enough or not is still debatable. On the more positive side of the benefits for mega constellations, it's expected that 14,000 small satellites are expected to be launched by 2030, and 84% of those are expected to be part of mega constellations. So there's a lot of satellites being invested and manufactured for useful mega constellations. So that's driving these markets and the launch and manufacture markets, and it's expected to cause them to triple over the next decade to $35 billion and $19 respectively. So by having these mega constellations and services such as SpaceX provides, it allows us to reduce the price per kilogram that we need to get into orbit, which allows more people to have access to space operations and get their satellites into orbit than previously they might not have been able to. And there is a high demand for the services that these mega constellations provide, as currently only 63% of the global population have access to internet, and these services aim to help get everyone connected. So those were my quick points on mega constellations, but I want to open the floor to the audience on what are your opinions on mega constellations? Are we pro them or against them? And how do we feel about the future of these mega constellations? And a general question is it sustainable? So please feel free to have a shout out or use the chat, and hopefully we can have some conversation going.
So I don't think, Sophie, you can see the, oh, so Catherine, you're going to Marshall, because I don't think, Sophie, you can see the hands popping up.
Yep.
Okay. Oh, we've got a hand from Michelle.
Oh, thank you. Hi, I'm from Open Research Institute, and this is an area that we have some work that you may already know about. We've met with the United States FCC, so it's about a year ago in October of 2021, and that meeting led to an ex parte filing on the debris mitigation rules, which is, as I'm sure you all know, are coming about with lots of news happening in the past month. And so what we learned was exactly what has been said here. They would really like to see much shorter, more focused missions, and that the disposal be done in much less time. And this leads to good things. And I think we can get behind it. And yes, it adds a lot of cost to do attitude control and propulsion and avoidance to LEO. So we discussed at that meeting 2 different types of orbits for educational, amateur, and scientific payloads. And the one that's probably the most relevant here would be a modified HEO. So instead of trying to fight it out at LEO to have a highly elliptical orbit, and then you raise the lower altitude to not cross over any of the constellations, the FCC was enthusiastic about this. The repercussions are that you will have a higher delta V. It's a little more challenging, but with the reduced mission time and all that, it may not be the 2 things may not be conflicting. So I think this presentation is accurate and timely, and the discussion needs to be had on how to actually go ahead and accomplish these sorts of things in the open source community. So we currently have an open source HEO project or proposal where these things are incorporated into the design, and moving forward with that. So there are repercussions to these rules, the expense and difficulty to modify the orbits. The other orbit that we discussed was to straight to graveyard, so to go out to GEO but go straight to graveyard and operate from there. And they're not opposed to that. You have to have a very specific and well planned out mission statement from your team in order to do it, but it kind of avoids duking it out for a GEO slot but you get the benefits of a geostationary geosynchronous type of orbit. Obviously, once you're in disposal, it's a different orbit. It will wander around, but to many communities, this is exactly what they want. So, so thank you. Strongly happy to see this sort of thing discussed here and presented, and just wanted to let you know what we've been up to and what we've found out and what we're trying to accomplish in the open source space community. Thank you.
That's great. That's really great to hear. Thank you.
Thank you. That's really interesting, actually. So, so the HEO orbit. So operating in this HEO orbit, is that what they were thinking about, where you actually have your satellite in the HEO orbit and you make use of that orbit and it's out of the way? Right. Oh, okay.
Well, yeah, there's two different ones. The disposal orbit would be at GEO. The highly elliptical one would be in orbit, and that's of great interest to amateur and for some scientific and regional communications groups, and so it's of interest. It's also a lot less expensive than some of the other orbits, circular ones and GEO. But to most folks, it you know, from a constellation perspective, for a highly elliptical orbit, your essentially your constellation would need to have at least 3 or 4 for global coverage. So.
Right, okay. So if we can propose for the constellation people to use these orbits, it clears up. Makes okay. So
yeah, it makes sense for some commercial applications, like in the past, emergency communications projects and launches have happened that use this particular orbit. In general, though, the commercial constellations are going to really like HEO and probably stay there for the foreseeable future, just as you've outlined here in this talk. For open source and for educational, scientific, and especially amateur, kind of avoiding the orbital shells, not crossing them, makes it much more likely that you will get approval for your launch. But it does have repercussions on cost and complexity.
And I guess the other aspect is that if you start using the GEO graveyard orbit as a operational orbit, then you may have to change the GEO graveyarding orbit, because then you're starting to create more satellites in that area.
Yes, there are always repercussions to everything. Because
sorry, carry on.
Oh, from an amateur radio perspective, it's always been of use to go look for things that are not wanted by anyone else. That's kind of the sort of the vibe. And once you start exploiting the graveyard, operating from the graveyard, so to speak, then who's to say that might cause a lot of other people to be interested in it? So there's always unintended repercussions for doing creative and innovative things. But as of right now, that is one of the options open to those of us who want to do open source satellite work and get it up there, and can't compete or get included on commercial GEO.
Yeah.
Cool. That was really useful and helpful. We've had a question come in from Isaac. Which companies are working on active debris removal of space debris? There are several players in that area.
Did you want to talk about that, Catherine? Or
I can think of a few obvious ones. So Astroscale, they're certainly pursuing that area at the moment. I think they're a system where it's more cooperative, where a satellite launches with a system that then Astroscale can then use to bring them back down. I think that's more their philosophy. ClearSpace, they're looking at technologies. Angie's probably a better place to talk about their capability.
So that is more about attaching yourself to a satellite, whether it's active or passive, by using, something like the separation system, or actually encompassing the entire spacecraft with arms, and bringing it down sort of like safely, releasing it at a lower altitude, so that it then would burn up. So yes, and they can do. I think their first demo mission is for a ESA part of a rocket. So it's a non-cooperative dead target that they're initially trying.
I think it's fair to say that active debris removal have still got a way to go. And so I think both Astroscale and ClearSpace are sort of more one-off bigger things, aren't they? And as we get more and more debris at the smaller scale, I think there are people looking at how you might hoover up smaller parts, but I can't comment particularly on any. I can't think of any particular company off the top of my head.
Right. I think a lot of them are still in the kind of VC, that kind of raising funds stage. I know when I've been at various conferences and the like, I have spoken to various companies who are looking at different methods and different approaches. It is an interesting arena, especially when you're looking at needing to put something onto a spacecraft to allow you to be able to remove said spacecraft from orbit. And I know, as probably some of us who do spacecraft design here, real estate on a spacecraft is precious, especially for most of us. What we want to put on the outside is our solar panels, our solar cells, our comms devices and the like. And so there have been some interesting discussions around kind of how you persuade people to give up some real estate to actually allow them to do this kind of these cleanup operations. And also, on some of the larger spacecraft, you might have more opportunity for that. But as sort of we've talked about here is well, you get a lot of CubeSat constellations, right? A lot of small CubeSats, and those are typically the items that don't perhaps have the propeller prop systems on them and the like to actually allow you to do the active putting yourself in those orbits which are preferable to to get out of the way of other bits and pieces. And as some of you may appreciate, a CubeSat is quite a small scale structure. You're talking kind of like 30-40 centimeters by sort of 20 or so by 10. They're really not very large, and real estate on those items are even more precious than they are perhaps on some of the large spacecraft. So I think it's going to be a really interesting challenge to balance off almost those competing needs. Everybody wants to see that sustainable use, but it's going to be how you incentivize people, I think, to take some of that pain, especially at the moment with a lot of the technologies for some of that active debris removal being quite immature. You're almost taking a bit of a a bit of a crystal ball gazing to see which is the option you should be putting on your spacecraft so it can be removed in the future. And I think that's an interesting conundrum as well to be resolved. So I think it's going to be interesting to see what shapes out in the active debris removal market. To see what I don't say wins, but what becomes, I guess, the norm, the de facto. I do know that I think I can't remember the company offhand, which is irritating, but there are a couple of companies that are looking at putting out, in effect, open source like the bits you would bolt to your satellite to allow you to capture. So like open source designs for plates and things which are a standard, which you could take and use. But again, you're kind of beholden to the fact that if you go for that, I guess, rather than the kind of something that comes along and just scoops you up, if you're looking for that active, where you put something on to actually engage with another satellite, you're committing yourself to having to find the right one that's going to work. So it's an interesting, and I think we'll see a lot of growth in this area before kind of it shakes out to see what comes out on top.
I think one of the other problems is, though, that with mega constellations, I think you have to rely on the constellations to bring themselves down, because until you can have an active debris removal system that isn't a one up, one down, it's going to be very difficult to remove lots and lots of satellites from those constellations. So I think they very much have to be cognizant and actually bring themselves down. Because if you're talking about the order of satellites that Sophie was talking about, you can't launch another 3,000 satellites to bring those 3,000 satellites down. So they've really got to be capable of doing that themselves, I think. And I believe that should be part of the licensing. You shouldn't be allowed to launch a huge constellation like that without that clearly mandated approach to removing yourself when you're finished.
And I think that's going to take a universal approach, isn't it, for license? Because at the moment, so you can go to different places to get your license depending on your, I guess, where you're launching and operating from. And so I guess, Angela, it'll also need the different, I don't know, institutions is the right word, but those different geographical areas to also come up with a common.
Yes, it needs to be more coordinated.
Yeah.
Yep, exactly. So, and also when you so thinking back to the orbit technologies, there's trade-offs even. So obviously fuel and propellants and propulsion systems is a good way to go, but they're difficult to accommodate, particularly on very small satellites. And there could be appreciable delta V that you might need. So people talk about sails or tethers, and they're slower, but they increase your drag area, so bring you down quicker. So it's a bit slower, but they've got the disadvantage of they give you a bigger area, so they make you a bigger target as well. So there's a heck of a lot. There's a massive trade space in terms of coming up with techniques and how might be the best approach to make. So yeah, and good tracking obviously is really important. Okay, I wonder on the constellation front, there's quite a lot of mega constellations proposed to meet the market demand. Is there really a market for all of those, or is it a case of once one of them's established the market, does then the market disappear for the others? I don't know. I don't. Is there a market for that many satellites? It's an open question. I have no idea. I'm not a business person, so. Any thoughts? No.
I think with many of these future-looking numbers of spacecraft, a lot of those will fall by the wayside.
Yeah.
Just naturally, they'll be very good at getting VC money, but then when they have to deliver, that's a different ball game. So I think a lot of those will not happen. That's just my personal opinion.
Yeah. Yeah. Mind you, Starlink is up there. That's definitely growing. It's probably the one that's going to capture the market, I suspect, because it's done the job it's got up there and launched. Has anybody else got any other thoughts, comments, pros? It's easy to get subsumed down into the disadvantage of mega constellations sometimes.
Yep.
Oh, yeah, we've got a hand up. Yep, go ahead, Aravind. Can't hear you. I don't know how I acknowledge. Yes, you can. If you can speak, Aravind, do you have a question?
Or if you can't make yourself heard, maybe you could type it in the chat. Might help.
Is there a way of acknowledging a hand up? I'm missing.
Don't think so.
Driven by
No.
the person who's done it, I think, in the end.
Okay. Feel free to put in the chat or to talk away. It's open discussion. Okay. So going back to the streaks on images. So I know from personal experience we're trying to do some astrophotography, whereas historically I would get 1 or 2 streaks in a 20 minutes period of taking pictures. I'm now at several streaks per image if you're doing a wide field view. So and series of streaks, because obviously as the satellite goes over you get a chunk in one image and a chunk in the next. So so certainly from a amateur astrophotography perspective, it's certainly getting to be a bit of a pickle. Aravind, how much of a threat is the case of high altitude drone constellation to a satellite constellation? So high altitude drone.
So are we talking about threats in terms of, are they going to cause collision debris, or are we talking about encroaching on like market space?
So, I know a bit about high altitude pseudo satellites, or HAPS. They're designed, they're like very, very light aircraft, unmanned, very light, just a couple of 100 kilos for a plane, solar powered with batteries, designed to fly over a region of interest at about 50,000 feet. And so the market effect, so they are definitely a future player in that market, and they've got advantages over satellites in that they can stay over a theatre of interest. So they can fly around, and with a smaller number of these HAP systems, you can fly over a region and provide probably comms, all sorts of applications that you would get from satellites, definitely. They're an emerging thing. The Zephyr plane has just recently completed a trial where it's been in the air for over a month, and it's broken its own record. So the developments are coming, and they're not the only manufacturer looking to do this kind of thing. They do have some limitations. They're solar powered, so they struggle in winter at northern latitudes to get enough power to operate. So there is an issue with that kind of thing, and they've got to be up above the weather as well. So there's a whole trade-off in the operating regime, and they have, payload capability issues. So could they replace satellites? They certainly have the potential to replace satellite capability in some areas. Definitely. You could argue it takes maybe some of the pressure off and not having to have so many mega constellations.
Would they not be complementary in some aspects?
Well,
so
absolutely.
You could have satellites plus drones, makes the value of the data so much greater. Because of course absolutely. you can also bring the plane down and change its payload if you wanted to, which is easier.
And you can bring that and service it as well. So the longevity side of it as well, though they are quite fragile when you come to landing them. So certainly you change payloads, etc., and the replacement, and they're cheaper in the first place as well. And there is a complementary aspect. So you can imagine a sun-synchronous polar orbiting satellites providing your northerly latitude view, and where they struggle with coverage is in the equatorial regions, which is perfect for pseudo satellites. So you could have very much a complementary system between those two, definitely. And so is that a market? It's a different market, and certainly will be a growing market, and will take probably some business away from the satellite side, I would imagine. Definitely. It depends on the regions of interest and what you're trying to do, I think. Does that answer your question? Or discussion? So yeah. Okay. Great. Are there any other comments or thoughts?
I was going to ask, Catherine, you were talking about the astronomy photographs just before this question. Is there anything that astronomers can do on the ground to help mitigate the issues of these streaks, or is there anything they can do on your side, or is it pretty much up to what comes across the field of view?
I can't stop a streak appearing in my image. I can edit it out afterwards. I believe there are programs. I was talking to someone else who did astrophotography yesterday, and they have an automatic program to edit some of it out. I can edit it out by hand, but if you wanted to do scientific work, then that becomes a bit problematic, because you're removing data and stuff like that. Okay. So, and also it's how accurately. So for me, from an amateur just producing an image, I can delete the streaks, and I'm normally stacking images, so I can remove a streak in one, and the chances of that streak being in exactly the same place in another image is actually quite small, so I can get around it that way. But it's the amount of work. So I delete my streaks by hand, so it's really tedious. So, but there are algorithms around that you could probably use to get rid of them automatically, which would help with that. So yeah.
Interesting.
I guess something else to think about with mega constellations is the robustness of the satellites. Because if you're putting up so many satellites at a time, you may not need those satellites each to be as robust as if you're putting up one spacecraft, because you are assuming a reasonable attrition rate. I think, doesn't Starlink assume a 5% satellite failure rate, which is actually quite high?
Yeah.
And so, you know, what one concern is if you have a high failure rate, then that will also start to create a reasonable amount of orbital junk, and we're back to the debris situation again.
Definitely, yeah.
Yeah. At least I think with Starlink, if it fails immediately, then it comes down because they launch them so low, which I think is one reason they do that. But it does show a bit of concern, you know, that we could have people doing that. Having a lot of single string spacecraft, maybe, that also, you know, you have single failure and that's the satellite over. So that's another aspect that I think probably needs to be addressed as well.
Yeah. And they had a case in point where there was a solar flare while they were quite low, and it knocked out quite a lot of their satellites, but they were all quite low, so they came down quite quickly, I believe. But
I think that the number was quite high. I think it was like 60 out of 65 or something around that much.
Yes. So it is a concern, isn't it? And not all satellites in those altitude bands have the capability for collision avoidance. I wonder sometimes, we've got a capacity in the tracking side, in terms of the facilities that are currently doing satellite tracking. Have they got the capacity to differentiate the number of satellites, to accurately track and report those numbers of satellites? Are the tools there? I'm assuming we're going to have to augment or improve the tracking side of it to be able to cope with the number of satellites up there. And then the software, and so improved accuracy in terms of knowing where the satellites are is also a great benefit, because at the moment the bubble, or the uncertainty with knowing where two satellites are, you may move a satellite when you don't need to because of the uncertainty of where they actually are. And as the numbers, and every time you move a satellite, that creates an uncertainty about where they are. And I don't know if I'm explaining it very well, but it could easily become quite a big headache.
Definitely.
So, yeah. Okay. So, yeah, there's lots of issues and problems coming that we need to manage and solve. So, okay. Any other comments or thoughts before I bring us to a close?
Well, I think what you're saying there, Catherine, about there's a lots of problems to come. I think one of the issues is, of course, that the constellations are coming ahead of those problems being addressed, and that's a situation which may get worse unless there's sort of like a hold everybody. Let me just get all my regulations and all my thought processes in order before you can send any more satellites, which is never going to happen.
No.
But
the commercial driver too.
Yeah. But it's the same. Regulations always seem to lag behind. The people at the front who are trailblazers will always get in there before the regulations have caught up.
Yeah. And there are other impacts, aren't there, potentially? So if you're launching a satellite and there's lots and lots of satellites coming off, it takes longer for the tracking side to differentiate all the different satellites being launched. Isn't that right?
Yes, and they have had some satellites remain unclaimed on some launches because they haven't worked out whose satellite it is, and it might have died before they've actually worked out that it was theirs. Wow. And they had to talk to it. There was a I can't remember if it was a company or there was an idea about putting like a little transponder on every satellite like you do with an aircraft that automatically engages when you separate. So you would have like a a transponder that you could lock onto, and it would say, this is who I am, which might help. But of course, again, that's real estate power and volume that people don't want to use because they want to use it for payload and providing a more more commercial revenue.
Yeah, I was speaking to a company from the Spacecom Expo, and they've got a little laser reflector, a tiny little laser reflector that you could put on, but also they were investigating a film that you could put on the reverse side of deployed panels, for example, which aren't used for anything else, that you could then use for laser tracking. So, but obviously you need a laser station, and you would have to have some indicator of where to look. So you'd have to have the coarser information, and then that's a service, which I assume would be a paid for service, which not everyone would use. But that might be a way of for a small satellite, if they're wanting to mitigate some of these things, maybe they could sign up to a service to provide more accurate tracking, perhaps. That's a potential thing for the future. That's in early development, I think. So there will be lots of different technologies and new products that will come out from trying to solve this problem. So, okay. Okie dokie. Any other comments? Right, I'll draw the meeting to a close then. So thank you for joining us today. It's really been a pleasure. Nice to have some discussion. Thank you, Michelle and Aravid and Isaac, for your questions. That was really nice. If you're interested in the open source satellite program, there are a number of ways of getting involved. You can sign up to get updates of what we're doing. We can follow us on LinkedIn and Twitter, example. You can contribute to projects in areas such as software and hardware, mainly in software at the moment. If you're working on a mission and would like to, or considering developing a mission, you could be an early adopter, which would just come and talk to us about that if you're interested. Dawn Aerospace were fantastic guest speaker back in July. If anybody else is interested in being a guest speaker, that would be absolutely fantastic. It helps us bring extra dimensions and extra thoughts and perspectives to the session. So if you are interested, just drop us a line, and we'll be very happy to talk to you about that. Or you could sponsor us and contribute to what we're doing to enable us to accelerate our developments. So next month we're going to do a science topic. We have got a couple of ideas. We haven't picked the final one yet, so the title will be announced soon, but they will be very sciencey, and that will be Thursday, the 20th of October at 4:30 BST. So if you would, we will be advertising via the usual means, via Eventbrite, etc. So do feel free to join us next month. Okay, so I'd like to thank Sufi for his excellent talk, and thank you all for joining us. Sorry about the last minute change of virtual venue, and thank you very much for your time. So thank you very much. Goodbye.